Okay, today class we want to talk about parallelograms, and parallelograms are a quadrilateral with both pairs of opposite sides parallel. We also want to talk about four properties of parallelograms. We'll talk about these properties in forms of theorems, and the first theorem says if a quadrilateral is a parallelogram, then its opposite sides are congruent, which means that PQ and SR are congruent to each other. So let's write that down. PQ is congruent to SR, and that PS is congruent to QR. That PS is congruent to QR. Now that we know that opposite sides are equal, let's look at example 1. In example 1 it says that FG is 5, so that means that JH would also be 5. And if HG is 3, that means that JF would also be 3. So now that we still know that opposite sides are congruent, we want to work example 2. In example 2, it still says that this is a parallelogram and to find the values of x and y. This time it's going to set up equations. So, opposite sides are congruent, which means that 3y plus 1 is equal to 16. And that 2x minus 4 is equal to 10. Now pause your video, work your problems, and when you come back they'll be worked and you can check your answers. Okay, class. Did you get y is equal to 5 and x is equal to 7? Okay, good job. Now let's move on to theorems 2 and 3. Theorem 2 says that if a quadrilateral is a parallelogram, then its opposite angles are congruent. So let's mark that. That means that P would have to be congruent to R, and that S would have to be congruent to Q. So let's write that down. Angle P is congruent to angle R, and that angle S is congruent to angle Q. Alright, let's look at the third theorem. If a quadrilateral is a parallelogram, then its consecutive angles are supplementary. What does supplementary mean? You're right, 180 degrees. Consecutive angles mean that those are angles that are right beside each other, not across from each other, not opposite, like in theorem 2. But in theorem 3, we're talking about angles that are beside each other. And in this example, it'll be the x's and the y's. So, in this example, we could write down that x degrees plus y degrees would give us 180 degrees. Now that we know this about the angles in a parallelogram, let's work example 3. Example 3 says, in this parallelogram, find the missing angles. Find all the missing angles. Okay, well, we know that angle S is congruent to angle Q because they're opposite angles. So we know that angle Q is equal to 70 degrees. Now, to find angles P and R, they're equal to each other, but since we don't know one or the other, we can't say what they are. But we still can find them because we've learned our theorem 3 that said that consecutive angles are supplementary. So we know that angle P plus angle S equals 180 degrees. So since we don't know P, we'll say P plus angle S is 70 degrees equals 180 degrees. So if we subtract 70 from both sides, then we get P is equal to 110 degrees. And if P is 110 degrees, then we know that angle R is also 110 degrees. Well, let's do one more example. Example 4. Example 4 says that parallelogram PQRS, in this parallelogram, find the values of x and the values of all the angles. So to find x, you have to know something about S and Q. Well, we just learned that angle S and angle Q, they're opposite each other, which means they're equal. So we need to set up the equation that 5x minus 40 is equal to 2x plus 50. Now pause, work your problem, and when you come back you can check your answer. Okay class, did you get x is equal to 30? Good. And if you know that x is 30, then you can find all of your angles by subbing 30 into x. So we could say 2 times 30 plus 50 is going to be 60 plus 50, which is 110. So we know that angle S is equal to 110 and angle Q is equal to 110, and we know that angle P is going to be 180 minus 110, which is 70 degrees, and if angle P is 70 degrees, then angle R is also 70 degrees. Okay, let's move on to the last example. Okay, now that we're back, we want to look at the last example, or the last theorem. Theorem 4 says if a quadrilateral is a parallelogram, then its diagonals bisect each other. This is kind of cool. You can say that means that if this was T in the middle, means that ST is congruent to QT, and that PT is congruent to RT. So let's write that down. We said that PT would be congruent to RT, and that ST would be congruent to QT. Alright, now that we know they bisect, that the diagonals bisect each other, what will we do to work the example underneath? Since it involves x's, the problem tells us to find x and QT, where there's your t. And so what would we do with the 2x plus 10 and 3x plus 1? You're right. Those would be equal to each other because our rule said that diagonals bisect each other. And when you bisect something, it's like in science when you cut it in the middle to cut it open. Well, these bisect each other. They cut each other into two equal parts. So our problem looks like this. 3x plus 1 equals 2x plus 10. And just in case you've struggled on the previous problems with solving equations with variables on both sides, I'm going to run through this one with you, and that will be your lesson. So on this one, you want to get your variables on the same side. You can see that there's two sides of the problem. You've got x's on the right and x's on the left. So let's move this 2x over to the left by doing the opposite. So we end up with 1x plus 1 equals 10. And now we've got a number on the left and a number on the right, so we want to get these numbers on the right. So we have 1x is equal to, because the 1's disappear, 9. So our answer is x equals 9. Okay? Now, it asks us also to find QT. And to find QT, we just sub our 9 in for our x. So our problem was 3x plus 1. So let's sub in our 9. And so QT is equal to 3 times 9 is 27, plus 1 will be 28. And these are the kind of problems we're going to work on the day that we do this lesson on parallelograms. Thanks so much. Have a great day.